morning, everyone. How did the homework go? Okay. Class number 28. Okay, we'll look at this problem and then we'll move on to chapter 12 today. So number 28. Okay, so we have of x equals sine x squared, and the question is, did I assign 28, Chris? Which section is that? Grace, which section?
Oh, sorry. I meant to put 38. Sorry about that.
Okay.
There. Sorry.
That's fine. So 38, we have integral from, it's the same type of function, 0 to 0.2 of sine x squared. And it's like the one we did yesterday. The idea is to write this as a series and basically approximate it with an error of less than 10 to the minus 4. So to do that, first we need the power series of sine x squared. Once I find this, then I integrate term by term and I go to the integral. So sine, we don't know sine x squared, but we know sine x. So sine x is x minus 1 over 3 factorial x cubed x5 minus 1 over 7 factorial x7 and so on and so forth. Okay. So we know that at the end we want an error less than 10 to the minus 4. So I'm going to stop at the first 4 terms. And if I feel that I need more, I'll add at the end. Sine x squared now means I plug in x squared for x, which can give me x squared. If I put in x squared for x and I cube it, I'm going to get x6 plus. I put x squared for x and then I will have x10. I put x squared for x plus etc. Okay. So now the integral. So we need to integrate from 0 to 0.2. It means we have to take this expression and find the antiderivative of that and evaluate between 0 and 0.2. Okay, so let's find the antiderivative. So it's going to give me 1/3 x cubed minus 1 over 3 factorial x6. It means x7 times 7 plus 1 over 5 factorial times 11, x11, minus 1 over 7 factorial times 15, x to the power 15, and so on. Now we have to evaluate, so we find to integrate term by term because we're finding the integral, and then finally we do the evaluation. At the upper limit, minus at the lower limit. Minus that. Minus at the lower limit. But at the lower limit, everything is 0, so minus is 0. So this gives me that the integral is given by this series. Okay. Now we need to find the error up to 10 minus 4. Now this is alternating, and usually those problems will involve alternating series. Otherwise, it's hard to find the error. So we're going to do exactly like yesterday. So suppose this is S2. So the question is, suppose I estimate it with S2, the first 2 terms. the error is going to be less than this, 1 over 5 factorial times 11 times 0.2 to the power 3. And the question is this less than 10 to the minus 4? If it is, I am done. If not, I'm going to move one more term. So I have no idea what this come up to. So we computed. I will have 0.2 to the power 3 divided by 5 factorial is 120 times 11. Okay, I'm done. Okay, this is 6.06 times 10 to the minus. That's definitely less than 10 to the minus 4. So we're going to use S2 to estimate, and it will estimate the actual value of the integer with very, very, very small error. So the estimation is 1 over 3 minus 1 over 3 factorial times 7 to the power 2. And now it's just a matter of evaluating this expression, and this will give me S2. Okay. So I'm really evaluating, basically I'm estimating this integer, that one of those integers I said yesterday we cannot find as a simple function. The only way we can find the antiderivative of sine x squared is as a series. There is no other way to find the antiderivative. And this would be my estimate. All right. So today we're going to move to the following chapter 12, parametric equation, polar coordinate, and conics. So today we're going to talk about parametric equation. So 12.1, parametric equations. Okay. So what's the idea here? The idea is the following. Let us suppose to motivate the equation, motivate as follows. Let us say we have the following. We have a curve, something like that. And my pen is out of ink. Okay. So we have a curve. This is my curve. It goes like that, it wiggles around, and goes like this, okay? And what we need is a way to describe this curve. I want to describe, so I want to give you the power that a certain description, so that if you use my description, you can come up with a curve like this. So how can we describe a curve? To describe this curve, we're going to imagine the following scenario. We imagine that we have an object, and this object is moving along this curve. So a certain object moving along this curve. We start right here, for example, it moves all the way here. Okay. And the way I will describe the curve is as follows. I will tell you at every moment in time, where is my object? So I introduce time, as we're going to call it parameter, and I tell you for every moment in time, what's the position of my curve? What's the position of my point? So imagine an object moving. So its position on the curve, its position change with time. So the way I'm going to tell you, describe the curve that this guy that this object is moving on, I will tell you for every time what is the position of the object. But how can I give you the position of the object? I can give you the position by giving you two functions, f and t and g. The first one will give you the x coordinate of my object at time t, and the second will give you the y coordinate of the object at time t. So as time changes, the f and g change. As the f and g change, we know where the object is moving along the curve. So how do we describe a curve? We describe, so it's my curve C, we describe the curve as follows. So we describe the curve C by basically giving the coordinate. We describe the curve by giving the coordinate of every point on the curve as a function of a parameter t, that we think of it as time. Okay, so the way I'm going to describe it is exactly by giving you the coordinate of every point, but the coordinate will be given in terms of a parameter t, that we think of it as time, to make the idea very, very easy. So the curve will be given as follows. So the curve will usually be given using the following equation. Using equation of the following form. X as a function of t, which will represent the x coordinate, y g of t. So we describe the curve basically by giving you, as I said, for every moment in time, the x and y coordinate. X as a function of t, y as a function of t. So those equations, so that's how we're going to give it. Those equations are called parametric equation. Parametric equation, and t is called a parameter. Usually, the easy way to think about t is as time, because that will make the concept fairly easy to understand. T is called parameter. So we're going to do a bunch of examples to explain this idea. Okay, so let's move on. So I'm going to do 2 or 3 examples today. So example number 1. Suppose we take a curve. Let's consider the curve given by the following parametric equations. X is, let us say, t squared, y equal t plus 1. We will understand this very soon. It's actually easy, where t is positive. So let us consider the curve given by the following equation. So what does this whole thing mean? So question number 1 is sketch the curve by basically plotting point. Let's see what this whole thing is about. So the way we're thinking about this is as follows. We have an object which is moving in the plane. Every time its x coordinate, the position, x and y are given. Whatever time t is, its x coordinate is t squared, its y coordinate is t plus 1. And the question is, we can describe the curve that this object is moving on. So we're going to make a table like we do back in middle school, a table. And this table will have t as the parameter, the x coordinate at time t, and the y coordinate at time t. And right here, I'm going to sketch the curve. Since I'm assuming t positive, actually we don't have to, but for this example, first example, I take t positive. So I say, okay, I take several value of t, and I try to understand what's happening. If t equal to 0, what is my object? Its x coordinate, that's the way we think about it, is 0. And its y coordinate, I plug in 0 for t here, is equal to 1. Which tells me that initially, when t equal to 0, the object was at the point 0, 1. 0, 1. So the object was right here at t equal to 0. That's the way we are understanding this. At t equal to 1, what is my object? Its x coordinate is t squared. Its y coordinate is 2. So after 1 minute, if you want 1 second, the way you want to take the unit. So for t equal to 1, my x coordinate is at 1 and my y coordinate is at 2. Right here. So this is at t equal to 1. So my point is at 1, 2. Now at t equal to 2, my x is at 4, my y is at 3. So at t equal to 2, my x is at 4, so this is 1, my 4 should be somewhere in here. And this is 3. Okay. Now what's happening in between? Before I keep going and taking more points, let us understand what's happening in between. Between 0 and 1, what's happening to the x coordinate? X is t squared. So as t goes, so this is my parameter t, which is positive. As t goes from 0 to 1, x is increasing because x is equal to t squared. And the y coordinate is increasing because it's t plus 1, so actually it's increasing. So as the time moves from 0 to 1, the x coordinate basically increases. It means the object is moving to the right. And the y coordinate increases. It means the object is moving up. So basically the object is doing that. Even though we don't plot point, but we know that's what's happening to the curve. Between 1 and 2, again, the object is doing this. So that's the path that the object is doing. For x equal to 3, I am at 9 here, and 3 plus 1 is going to give me a 4. So at t equal to 3, this is a 9 here, and this is a 4 right there. It means this is where we are at t equal to 3. Okay. So basically, you can imagine those two equations that we call a parametric equation describe the following motion, the motion of a particle that starts at this point, which is here 0, 1, and it moves in this direction. And which curve it describes? It moves along this curve right there. So that's how we describe the motion. Now question number B is the following. Eliminate the parameter t to find an equation that relate x and y. So eliminate the parameter t to find an equation that relate x and y. Okay, so what is this question asking us about? What the question is asking us about is the following. At every moment t, for every moment t, the point is at t squared and t plus 1. That's its x coordinate, and this is the y coordinate, okay? Finding a relation that relate x and y. It means find an equation between x and y that holds regardless what time is. So let me do the first one, and then the second one will be easy. So the idea is that what's the equation that relate x and y that holds no matter what x is? So the way we think about it is like this. For each time t, no matter what time is, for every time, x is always t squared, and y is always t plus 1. Okay, and the idea is, so no matter what t is t equal to 2, x is 2 squared, y is 2 plus 1. That's a 3 squared, and this equals 3 plus 1. The idea is that we're going to do the following. But from y, we're going to solve for t in one equation and plug it into the other one. So for y equal t plus 1, it means for every time t is equal to y minus 1. So no matter what time is, the time is the y coordinate minus 1. Now I plug in this into the expression of t. So now we're going to substitute, and then I'll explain what's really going on. We're going to substitute y minus 1 for t in the expression x equal t squared. And then we get the following. X equal, instead of t, I put y minus 1 squared. Okay. So what does this expression tells me? Which is a parabola. So what does this equation tells me? This equation tells me that this curve right there, the equation of the curve, it means in terms of x and y, the equation of the curve is x equal y minus 1 squared. That's the equation of the curve. And x equal y minus 1 squared is basically a typical parabola. It's like x equal y squared, but it's moving. Instead of going up and down, it's going to move. It's going to open left and right. That's exactly a parabola. So what this equation tells me that this curve physically is just a parabola. It's this parabola, x equal y minus 1 squared. But the parametric equation tells me a little bit more than that. The parametric equation doesn't tell me it's a parabola. It gives me the shape. But this parametric equation, its benefit is to tell me how the object is moving along the curve. So each one will have its own benefit. This tells me how is the object moving. It's telling me the object starts here and it moves in this direction. So if I'm describing how an object moves with time, I need the parametric equation. What this tells me is that physically this curve is the curve x equal y minus 1 squared, which is the information I don't see in this equation. So each one of them has its own benefit. The first, that's its benefit. I know the direction of motion. Eventually, it's going to tell me to the speed, how fast the object is moving, which you guys will take into the calculus 3. But in this course, it tells me the direction of motion. This tells me physically what this curve is. Physically, this curve is x equal y minus 1 squared, because that's the relationship between x and y at every moment in time. So let's do a couple of examples along the same lines. Okay. Example number 2 is the following. Okay. Again, example number 2 is a simple, all those ideas are relatively fairly simple. So example number 2, let me take the curve, CB the curve given by. Okay, x equal 3 cosine t, y equal 3 sine t, where t is between 0 and 2 pi. Okay, and the question is like before, sketch the curve by plotting point. And the second is after we plot point and we do everything, okay, what type of curve we're getting. So sketch the curve by plotting point. All right. So I'm going to make a table. That's t, that's the parameter, so that's time. As time changes, the easiest way to think about t as time usually. And this is my y. So for every t, the x coordinate of the object satisfy is 3 cosine t. The y coordinate is 3 sine t. And right here, we're going to sketch the curve. Okay, at t, we are between 0 and 2 pi. At t equal to 0 initially, what is x? X is 3 cosine t. So x is 3 cosine 0. Now cosine 0 is 1, so this is a 3. And y is cosine of 0 is equal to 0. So at t equal to 0, x is 3, right here. and the y is 0. So that's where we are. Now, since we're dealing with cosine and sine, we now want to take a nice values for t. So I'm not going to take t equal to 1. That's absolutely kind of ridiculous. So we're going to take nice values of t because I'm dealing with sine and cosine. So I'm going to take t equal pi over 2 because that's the ones we know a lot. Okay, at pi over 2, if t is pi over 2, x is 3 cosine pi over 2, it's a 0. 3 pi, that's equal to 3. So if t is pi over 2, x is 0, and y is 3. So this is my 3 right here. This is t equal pi over 2, I am here. Okay. Another question between 0 and pi over 2. So it means as time, think of time changing from 0 and pi over 2, what happened to x and what happened to y? Is x increasing? Is y increasing?
X is decreasing. Y is
Go ahead.
increasing. X is decreasing and y is increasing.
Yes, absolutely correct. Why?
I mean, you can just see through with the values.
Okay, how else can we see without values?
The graph too.
Exactly. Let's watch graphically what's happening. This is the graph of cosine. Cosine starts here. It goes down and up. That's the cosine. And this is the sine. It starts at 0, go up and down. And since this is 3 cosine, so it's a 3 in here, and it's a 3 in here, okay? So now what's happening between, and this is pi over 2. So that's represent the x coordinate, and really that's represent the y coordinate. So as t go from 0 to pi over 2, x is the cosine, so x is actually decreasing because the cosine decrease. The sine increase between 0 and pi over 2. It means the x coordinate decreases between 0 and pi over 2. It means we're going to the left. The y coordinate increases. It means we are going to go up. So between 0 and pi over 2, we're going to go x, decrease, y increase. We're going to go all the way like that. So now I am sure that this is the motion I am doing because I'm really also analyzing the behavior. All right, at pi. At pi. If x is pi, if t is pi, x is 3 cosine pi, which is a minus 1. And this is equal to 0. So at pi, we are right here. But what's happening between pi over 2 and pi? Again, I go to my graph. Between pi over 2 and pi, x is negative.
Shouldn't the x-coordinate be -3?
Oh my God.
Isn't the cosine of
Oh,
pi negative?
absolutely. Okay, thank you. Between pi over 2 and pi, what's happening to the cosine? The cosine is negative. It means my x coordinate is negative. And it's getting more and more negative till it hits -3. It means as time changes from pi over 2 and pi over 2, the x is negative. So we are in this quadrant. It's getting more negative. So the x is actually going that way. So we're going to the left. The y is decreasing because sine t decrease. It means we're going down. So between pi over 2 and pi, we're decreasing and we're going down. Okay, so those two graphs basically help me tremendously to fully understand the picture. And now we are at 3 pi over 2. This is 0 because the cosine 3 pi over 2 is 0. And the sine is negative. And finally at 2 pi, because we want to have to stop at 2 pi, the cosine is 3 and this is a 0. So between pi over 2 and pi, sorry, between pi and 3 pi over 2, the cosine is still negative. It means the x coordinate is negative, which means I'm right here. It's getting less and less negative. So the x coordinate is getting less and less negative. It means we're moving to the right. The y coordinate is negative because that, and it's getting more negative. So we're going to move down here. So we're going to go like that, this direction, and then we're going to move around all the way in this direction. And that's really the curve that we are going to describe. So this object is moving basically along this curve, and which direction is moving in the counterclockwise direction. So it starts at 0 and it's moving in the counterclockwise direction. So that's really what this gives us. It gives us actually the direction of motion. Okay. Now B, I will take 2 minutes extra because I know your quiz here, but please listen so you can do the homework. B is to find the equation that relates X and Y. The idea to find the equation that relates X and Y is to find a relationship between X and Y that holds for every time t. What's the relationship between X and Y that holds no matter what the time is? So how are we going to do this problem? X is 3 cosine t. Y is 3 sine t. And I'm going to find how can I relate X and Y to each other so that no matter what t is, the relationship holds. So what's the equation that relate X and Y? Anybody can? Okay. Whenever we see cosine and sine, we go back to our identity. So that's the famous relationship between sine and cosine. And this is the relationship I'm going to use to find equation related to X and Y. But how can I use this relation to find the equation? We do like that. We isolate the cosine here. Cosine. I'm going to isolate my Y here. And then I say cosine squared plus sine squared equal to 1. So I'm going to square both sides. Means basically now I'm going to evaluate that. This is equal to 1. It means if I take x over 3 squared plus y over 3 squared, I get 1. So this is the relation that exists between X and Y independent of T. No matter what T is, this is equal to 1. It means this is equal to 1. Now, a little bit of math tells me that this is X squared over 9 plus Y squared over 9 is equal to 9, to 1. Now, I multiply by 9 across, and it will give me X squared plus Y squared is equal to 9. That's the relationship that exists between X and Y, no matter what time T is. Now, anybody know what's the equation of what this? Anybody has any recollection that this equation represents the equation of what?
Of a circle.
Exactly. That's a circle centered at the origin with radius 3. It means effectively, my object, which is here, from the equation here, we don't see it exactly, is actually moving along a circle. So this graph here I drew is an honest to goodness circle. It's centered at with radius 3, but the motion, the way the motion is a counterclockwise. It means the object starts at 0 and move in the counterclockwise direction around the circle. Okay, I definitely stop right there. You guys can start your quiz. Comment about the quiz. Problem number 1, it has 2 parts. The quiz is not hard at all. Problem number 1, it had 2 parts. For those, you need non-series to find the Maclaurin. For the last one, you need to use the formula for Taylor to find the series. Okay, get going.
Professor,
I'm listening.
could you put up the example problem from the beginning of class?
The one with the sign?
Yeah, the sine x squared.
Okay, let me give you sine x here. That will do.
Oh no, I didn't finish writing down.
Ah, okay.
Yeah, sorry.
Okay. All right, I'm not very organized around here. Usually when I write something, I throw it somewhere in the room. Here it is. Okay.
0. Oh, I'm almost done.
That's okay. Take your time. You guys know I give you all the time.
Okay, thank you. All done.